we're going to learn the formula for finding the area of any triangle. But to do that, we're going to start with a rectangle again.
What?
The dimensions of this rectangle are 3 meters by 4 meters. So, what's its area? Well, using our formula, we know that the area would be 3 meters times 4 meters, which is 12 meters squared. But now, what if we were to cut this rectangle exactly in half along a diagonal line from opposite corners? It forms 2 triangles. And because each of these triangles is exactly half of the rectangle, that means that the area of either triangle must be exactly half the area of the rectangle. We already calculated that the area of the entire rectangle is 12 meters squared. So the area of this triangle must be 6 meters squared, and the area of this triangle must be 6 meters squared, since 6 is half of 12. Aha! So the formula for the area of a triangle should just be half of a rectangle. So does that mean that instead of area equals length times width, it should be area equals 1/2 of length times width? Yep, that's basically it, but with one important difference. Instead of L for length and W for width, we're going to use 2 different names for our triangle's dimensions. We're going to call them base and height, and here's why. The names length and width worked okay for this right triangle because the right triangle is exactly half of a rectangle. But those names don't really work for other kinds of triangles, like acute triangles or obtuse triangles, because how do you tell which side should be which? So for triangles, we do something different. First, we choose one of the 3 sides to be the base. It doesn't really matter which side you choose, and in a lot of math problems, the base will already be chosen for you. Once we decide which side the base is, we imagine setting the triangle down on the ground so that its base is flat on the ground, like this. Next, we find the highest point of the triangle, which is the vertex that's not touching the ground. From that point, we draw a line straight down to the ground. The line we draw must be perpendicular with the ground. The length of that line from the tip of the triangle to the ground is called the height of the triangle. Oh, some people call the height of a triangle the altitude, which makes a lot of sense if you pretend that your triangle is a tiny little mountain. Sometimes the height line is inside the triangle, like with an acute triangle. And sometimes it's outside the triangle, like with an obtuse triangle. And sometimes it lines up exactly with one of the triangle sides, like with right triangles. But no matter where it is, the formula for finding the area of any triangle is the same. Area equals 1/2 base times height. So if we know these 2 measurements, base and height, we can just plug them into our formula to calculate the area. Okay, we already figured out that the area of this right triangle was 6 square meters. So let's practice using our new formula to calculate the area of these last 2 triangles. Our diagram shows that the base of this acute triangle is 5 meters and its height is 8 meters. So we plug those values into our formula for area and we get area equals 1/2 of 5 times 8. 5 times 8 is 40 and 1/2 of 40 is 20. So the area of this triangle is 20 meters squared. Don't forget that the units of measurement for area will always be square units. Okay, that was pretty simple. Let's try our last example. The diagram of this obtuse triangle tells us that the base is 4 inches and the height is 7 inches. So let's plug those values into our formula. We end up with the equation area equals 1/2 of 4 times 7. 4 times 7 would be 28. And then we can calculate what 1/2 of 28 would be by dividing by 2. 28 divided by 2 is 14. So the area of this obtuse triangle must be 14 square inches. Don't forget to practice what you've learned by working some problems on your own. That's how you really get good at math. As always, thanks for watching Math Antics, and I'll see you next time. Learn more at mathantics.com.